anyone want to come up and write the answer to number 1? Otis, you got it. Did anyone else have a different answer? So I saw a mixture of this and something else. Let's count these. So the y-intercept definitely is at -4. If we're counting these points, we're going down 4. 1, 2, 3, 4. Yes. Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is negative, but it's not 1/2. What is 4/10? Simplify. Great. So if you had that, that was right. Make sure you're being careful. And you could have done this a couple different ways. You had a graph, so you could have just counted your slope and y-intercept. Or if you wanted to do it algebraically, you had your 2 points. You could have found what those 2 points were, -5, -2, and 5, 6, -6. Found the slope that way, and either found the y-intercept from your graph or did it algebraically. Questions on 1? Anyone want to do number 2? So this is a lot of what we were talking about last class and the class before that. You have a point, you have a slope, and I'm going to show you how you could do this one on Desmos. So you have to use your point slope. That is something you'll need to know and remember. And then you can start putting pieces in. So this would be y minus our y1, which is 3, equals our slope of 1/2. Times x minus our x1. Or if you jumped ahead and made that a plus, that was also fine. I'm going to make it a plus now. Then you would still need to distribute. And then get rid of the 3 by adding it to the other side. So your final equation should have been y equals 1/2 x plus 5. Who all got that? Okay. Do we have questions on that one? Right. Before we do number 4, I'm going to show you how you could have done this in Desmos. Let's back. Okay, so I'm going to start off by typing in our line equation. When you do that and everything is lowercase, it's going to ask you, do you want to add sliders? You can hit all. You know what the slope was because it was given to you, so you can go ahead and change that. The issue is we don't know what the y-intercept is, but we do know that it went through the point -4, 3. So I'm going to type in that point. So then it kind of becomes a guessing game. You want to move your y-intercept until your line goes through that point. So someone guess a number. You may have figured this out already, so guess a wrong number. I think that's the actual answer. Guess a different one. Okay. So if I put in 6, I can see it's really close. So maybe if it was moved down 1, then that would be my answer. 5 was the correct answer. It goes through that point, so I know that is my y-intercept. So that's the way you could use Desmos to help you find the equation of the line. Again, you'd have to know what you're looking at because the question still asks you to write that equation. So you would have to still know, okay, this is my y-intercept, I need my slope, put those things together in your equation. Questions about that? I would say if you have time to look at the notes from 2 classes ago when we were doing this, not when we were given 2 points, but just given a point and a slope, and try to practice that on Desmos, so that's a skill you can use when it comes to the SLL. Anyone want to do number 4? One, there's important information in this. There's not really work for you to do, but could be done. If it says something about horizontal or vertical line, you should immediately be thinking your Poiseuille's. So if this is a vertical line, is this going to be an X or a Y? X. So then from there, you're just looking at what is your X value in this ordered pair. So we know it's an X, we know it's a vertical line, we know our X value is 4, you put all that together and you get X equals 4. Now, doing it on Desmos is going to be basically just what I just did. You would type in your ordered pair. And then, because it's a vertical line, you know it has to be an X equals, but maybe you forgot, you could type in both of these things. X equals 4, Y equals 5, to see which one is your vertical line that goes through that point. The only issue with this is if you confuse them. So if I say X equals 5, and Y equals 4. Get rid of the right. Then neither of them do. So keep them straight, and you could use Desmos to help you. But if you mix them, it may confuse you more. Questions on that last one? Before we jump back into our investigation, I wanted to mention one thing. You all got this on your desk. This is more SOL practice from now until, let me find my little thingy. I had it somewhere. From now until like April, May, you're going to be working through this. We're going to be going through it either by SOL standard, maybe multiple SOL standards, it depends. So next Friday, I think that's when I see you again next. We're going to go through all of SOL 1, A1. So I want you to try as many of those as possible. Try to use Desmos. You could do it by hand, either or. I know it's a lot, which is why I'm giving you a week to do so. So all of SOL A1, so numbers 1 through 17, I want you to do all of those by next Friday. And we'll go over those then. And then on next Friday, I'll give you the next ones, which will be due the next week, and it'll keep going like that. I'll also put them on Canvas of which objectives are due when. It'll be under the SOL module. So if you're looking for them, that's what there will be. Okay, questions on that? So this is something you should hold on to, not throw away, not lose track of. I do have extras, but it's a thick copy, so I'd rather not make a whole lot of extras, so make sure you hold on to this. As you're working through it, if you want to come see me, go over stuff, have questions, how would I do this in Desmos, any of that, you can come see me. Okay. Find this page in your parallel lines investigation. You need one. Were you here last class? Yeah, okay. We're going to talk through the questions and then start our perpendicular. So before class ended, you were to answer these questions. So I want you to tell me some of your answers. What did you notice about the slopes in each pair of equations? The slopes were different in the pairs of equations? I mean the y-intercepts are different. So what do we notice about the slopes? The slopes stay the same. Okay. Sorry. That's okay. So something along the lines of the slopes should have been the same. When you have parallel lines, the slopes are the same. And then what did we notice about the y-intercepts? I know this was answered already. I'm just asking you again. They were different. So with parallel lines, the slopes have to be the same, but the y-intercepts also have to be different. If you went into more detail, that was fine. I'm just putting the very basics. So if we were to combine 4 and 5 to make a general statement for number 6, what did you say? Or how did you answer that question? Or if you weren't sure how to answer that question, how would you answer it now? What could we say in general about parallel lines, about the slopes and the y-intercepts? Like, are you raising your hand? So I'm going to add a little bit more context to that. The m, the slope, will always be the same. And then the b, the y-intercept, will always be different. Then it asks you some questions. For this number 1, are these two equations parallel to each other? Yes, how do we know that? And yes. So they are parallel because the slopes are the same and the y-intercepts are different. If one of those apply but the other one doesn't, so like let's say they have the same slope but they also have the same y-intercept, they would not be parallel. Or if they had different y-intercepts but they didn't have the same slope, they would not be parallel. So they have to have both things. Are these two parallel? You said no. Why? The slopes don't match. They're not the same. They're like flipped. Okay. And then you had to name 3 lines that were parallel. You could have made these up. They just had to be parallel. So give me one. Y equals 2x plus 5. Okay, that works. Slope is the same, y intercepts are different. Give me another. Sheila? Say that one more time. Y equals 2x. Okay, that works. And then I just need one more. Lacey? Y equals 2x plus 2. You could have also done y equals 2x plus 3, made the y-intercept of decimal or a fraction, made the y-intercept anything else but -3, as long as it works. Okay. Then name 3 lines that are not parallel to y equals 5x minus 2. They just can't have the same slope. Give me one. Okay, y equals 3x minus 2. Slopes are not the same. Those are not parallel, correct? Give me another. Y equals -1/2x plus 2. Y equals -1/2x minus 2. Also not the same slope. That works. One more. Sheila. You could have also made the 5 negative, y equals -5x, whatever y-intercept you want. That would also not be parallel because they're different. Questions on parallel lines? So now we're going to do the other part. We talked about parallel, now we're going to talk about perpendicular. I'm going to give you 3 minutes. I want you to do what you did last class and plot these points, graph their lines. If you need rulers, there's some in the back. You have color pencils at your desk. Do that for the next 3 minutes, and then we'll come back and I'll show you. So you're going to have a bunch of graphs on here. I did what I did before, highlighted the ones that were already there, and then graphed in the others. So our blue line should look like those. Our purple line should look more like those. And then the orange one here. Okay. So as before, the next page has your equations and it has boxes for you to find the equations. You can either look at the graphs or you can do the math and find them algebraically. So I'm going to leave the ordered pairs up if you want to do the math, but remember you also have the graph. I'm going to give you 5 to 7 minutes to work through that. And then we'll talk about what perpendicular means. Are the equations you should have gotten, whether you did that algebraically or from the graph. Blue was y equals -3/2x plus 2. Purple, y equals 1/3 x plus 7, sorry. And then orange, y equals 5/2x minus 7. Before we talk about the answers to the bottom, anyone know what perpendicular lines look like on a graph? Yeah.
The same, but like with the other layers.
on a graph, how would it look? Otis? Okay, they do that. They cross at some point, but it's more than that. They don't just cross, because those would just be intersecting lines. Something else makes them perpendicular lines. And it's that they cross and make like a T. So like the blue line and there it is. Okay, I was looking for this other one. This blue line and A crosses and kind of makes like a T. We don't really want an X shape because that could be different. We want more like a T where it's like perfect. So if we're even though it's angled, if we're looking at it like this, it does make that T. So that is whatever answer that is. B and the blue line would be perpendicular. What would be perpendicular to C? The purple. It makes like that T. So C and purple, and then A and orange would have to be the last one. So write those two equations, your orange and your A, your blue and your B, your purple and your C. And then I'm going to give you 5 minutes to answer the questions on the back, and then we'll come back and we'll talk about them, and then we'll jump to our next activity. What did you notice about the slopes of each pairs of equations? I did see your hand. Otis, hello. The slope split, okay. Otis, what were you going to say? It flipped. Jasmine? Okay, so it's both things. So that's called a negative reciprocal, which we'll talk about later, but I'll put what you said for now. They flipped, and one is negative. So if you had something along those lines, or if you had one piece, add in the other. What about the y-intercepts? What did you notice?
The y-intercepts don't matter.
Yeah. So they could be the same, they could be different. It doesn't matter. I'll just say some were different or the same. Doesn't matter. So what general statement could we make about equations of perpendicular lines? Curtis?
It doesn't matter if the y-intercept is different. The only thing that matters is if our slope is different.
And
Negative or positive.
yes.
Depending on.
So let's shorten that a bit. Slope has to be flipped and one has to be negative. Y-intercept doesn't matter.
I just said if they have a flip slope on the
For number one, are these two perpendicular? No. What would those be? They would be parallel because they have same slope, different y-intercept. Are these two perpendicular for number two? Yes. Why? Correct. And the y-intercept same, different, doesn't matter. Yes. Give me 3 lines that would be perpendicular to y equals 2x minus 3. Otis, you can give me one.
What if you would have x percent?
Why is there no zero?
Yeah, I just.
Okay. Give me another. Kayla. One more. Now 3 lines that are not perpendicular to y equals 5x minus 2. Otis, give me one. Okay. These are not perpendicular because the slope is the same. Give me another. Lacey? Okay. Again, not perpendicular because the slope is the same. One more. Sure. Again, not perpendicular because the slope is the same. You could have also said 1/5 x plus or minus whatever, because even though it's flipped, one's not negative, so it would still not be perpendicular. You could have said negative 5x because now one is negative, but it's not flipped, so still wouldn't be perpendicular. So kind of like parallel, both things have to happen. All right. So you can use it as memory. You can also match it. I was trying to see what that was. So you guys have cards. We're running low on time, so you won't have a whole lot of time to do this, but I'll give you like 10 minutes to try to do as many of these as you can. So of these cards, you can either match them with what you think would be what would be parallel and what would be perpendicular. The equations go with each other. The graphs go with each other. I think there are more parallel than there are perpendicular, but I have to double check that. See how many of those that you can find together, and then you can either glue or tape them to your sheet. You may need to turn it sideways, put them closer together, use the front and the back, whatever works. If you want more paper, I can also give you that. So try and see how many you could do in the next 10 minutes. Okay? So what we just did was like to learn the basics of parallel and perpendicular lines. Now we're going to use that knowledge a little bit more. So I'm going to have you write these definitions down. Let's see if I can see this in. Hold on. So the definition of parallel lines are lines that never intersect, which we talked about. They have the same slope algebraically. You can also add in and different y-intercepts. There's a symbol off to the side. That means parallel lines. You'll see that a lot when you move on to geometry. Perpendicular lines are lines that intersect at a 90-degree angle. I'm going to change this. So that's like that T we were talking about, the 90 degrees. You'll talk more about that when you get into geometry. And the symbol for perpendicular lines is an upside down T. Algebraically, we know they're perpendicular if they have negative or opposite reciprocal slopes. And we're going to talk about that definition here in a second. The next one is talking about negative reciprocals. That is a fraction that's flipped and the sign is switched. So if it was positive, now it's negative, or vice versa. And it's flipped. So 1/2 is now 2, 2 is now 1/2, 3/5 is now 5/3, all of those things. few people to finish. I know some of you have already started writing what the negative reciprocals are, so if you want to do that, you're more than welcome to. We are going to do that here in a second. Anyone still writing down this definition? Jaden, are you, or did you finish? You said you did finish. Okay. Alright, so if we had to find the negative reciprocal of 3/4, what would that be? So flip it, and it was positive, we have to make it negative. So -4/3. What would the negative reciprocal of 2 be? -1/2. Negative reciprocal of -7/8. Positive 8/7. Now the negative reciprocal of 1. Just -1. So all your whole numbers are really over 1, so if you flip it, that would be -1/1, which just simplifies to be -1.
So if I would have wanted to make a more number, it kind of wrong. Just because it's not simple.
Correct. You need to simplify always. You may have seen this when you were mathing. Does anyone know the negative reciprocal of 0? Besides us. Lazy. It is undefined. So you can think about this like 0/1 would still be 0. If I flip that and make it negative, I have -1/0, but anything over 0 is undefined. So that's going to be one that trips you up, so be careful with that one. Remember that 0 and undefined are perpendiculars. Mathis. Okay. I think we'll have time to do one of these, and then we'll come back to it Thursday. Right? So here, we're given 2 sets of ordered pairs. We have to determine if they're parallel, perpendicular, or neither. How could we find that from these ordered pairs? Sophia? Find the slope. So if you need to write your m equals y2 minus y1 over x2 minus x1 off to the side, you can do that. These spaces are not that big, so if you need more space, feel free to grab paper, write off to the side. So we need to find the slope of the AB and the slope of CB, and see are they parallel, perpendicular, or neither. So if you want to label them, you can. So AB would be 6 minus 3 over 2 minus a -2. What would that slope be? 3/4. And then if we do the same thing for CD, we have 3 minus 0 over 3 minus a -1. 3/4. So are these parallel, perpendicular, or neither? Parallel, because they're the same. So you can either write out the word parallel down here or use the symbol. We actually have time to do 2. But do we want to do another, or do we want to stop here? So those for do another. Those for stop here. Yeah, that's right. You guys have been working hard today. So we're going to do some more examples next class. Finish the rest of these notes. There are Khan Academy that opened up today, but those are not due until March 3rd, so you have time to